Or do you have any questions?
Is the PCA the
The concentration
of
with,
weak?
yeah,
Okay.
PCA is the concentration of the weak acid, PCB is the concentration of the weak base. So let's solve a few problems. We have ammonium with concentration 0.02 mole per liters. And you know that the pKb value is 476. Find out the pH of that solution.
Was it the concentration of weak base times pKb, or add plus pKb?
Plus,
Plus, okay.
plus. Are you ready?
Yes.
I unlock the please write down the solution. Actually, this is not absolutely correct. Slide and where do you see how we present the compounds of units with their p-value? Right?
Yes, so I forgot to turn the
Yeah.
clarity. Yeah, okay.
Professor, I don't understand what you mean with this point. What do you mean p-value?
P-value, it means that we multiply to negative decimal algorithm and we don't work with concentration, we work with all digits.
Oh, okay, thank you.
Welcome. Do you recalculate it? Now it's better. So, that was everything for now as a theoretical part. We will continue with the experimental part in which I will actually measure the concentration of the hydrogen cation in a few solutions. With other words, I will measure the pH. But before this, I will share, do you download the notice for the today practical class already from our page? Can you hear me?
Is it practical 3?
Yeah.
Okay.
Please, everyone, download it. Those in the one with some values according of pH, according to which you calculate it. Here is it. Exactly. These are most of the solutions that I will measure now. Some of them. Now, I want from you for every solution that I show, for every solution that which pH I measure, to write down the value. That value, all of this must be written in your summary of the class. And when you come in the university, I will want from you, show me these summaries. Now, I turn on my camera. Just second. I hope it will be good enough, the quality, to be able to see everything that I measure as and show as a result. So, pH measure with pH meter the instrument technique as this one that I show you now, and also with the usage of pH indicators called litmus paper. There is a precise litmus indicator and universal. So, how is the quality? Do you see what is written at the labels?
No.
No. Still no. Maybe.
It's not like it's not focusing.
No, I don't know how to fix it. This is something from the camera, but with this online classes is like this. Very difficult, everything. Okay, I will tell you what is written at the labels. I tell you for every solution that I measure what is the pH and what is the concentration and what indicator I use. Now, please, I will tell you the solution which I start measuring. I will show you the indicators and all indicators that I use. I want from you just to listen, to watch, and to write down all of the results. So, as I told you, there is one option to measure pH with pH meter, which is the most correct way to measure the pH. But not in every laboratory there is a pH meter. The easiest way with which we find out what is the pH of one solution is with the help of litmus indicators, which can be universe. This universal pH indicator measures from 1 until 14 pH. It means that measure in all pH range. And as everything, when you are able to do so, to measure in all range, the mistake that we can make with this indicator is the highest from all other options. After that, a little more specific way and correct way to measure the pH is with use of this precise indicators, paper indicators. So as you can see, I have 6 different boxes. And this is the reason of this, to use so many different boxes, is because they measure pH in a very, very small range. For example, this one, the green one, which I show you, measure pH from 3.8 until 5.5. See how small range. The orange one measure pH from 9.5 until 12. The violet, the purple one, measure from 10.5 until 13. The pink one measure from 1 until 2.8. And the yellow one measure from 1.8 until 3.8. And this one measure into the neutral area, acidic and neutral area from 6 until 7.7. Not only the range in which with these pH meters, in this litmus we measure, but also the result we read at a different way. For example, for the universal indicators, that are the papers which I will use, I will put one very small drop from the solution to my litmus paper and see it change immediately its color. And now I check according to this one. It's not possible to see with that awful camera.
Miss, we can't hear you.
Now can you hear me?
Yes, but the audio is low.
No?
It's the same.
I think everything was because of the weak internet.
Oh, the camera is good now.
I'm very happy. That was I tried to fix until now. So, as I told you, with this universal litmus indicator, this one here, I will put just one drop and it immediately will change its color. And now I will set the color according to that color scale. And this color that I obtain is absolutely the same, which corresponds to pH 1. So for the solution of 0.1 normality hydrochloric acid measured with universal pH indicator, write down value 1, pH 1. Let's see what we'll obtain when we use a precise litmus indicator. This one, you can see measure from 1 until 2.8. See how it looks like. In the middle I have one area in which I have color, but without written value on it. This is the area in which I will put my solution for measuring. And you can see it immediately change its color, and now I check it according to that color's upper and down from that area. And here again looks absolutely the same as pH 1. According to the precise indicator and the universal litmus indicator, we obtain for solution of hydrochloric acid with 0.1 normality, we obtain pH 1. Let's continue with the next solution, which is 0.01 normality. According to that concentration, we must obtain pH 2, right? Let's see. Again, just one drop, and the color is changed immediately. I check it. Something happened with my camera. I'm sorry, but the internet connection is awful. And can you hear me?
Yes, we can.
I'm sorry, but the internet connection is just awful because I'm in a laboratory placed in a basement. And it's very difficult. I hope soon you will be here. Now, I measure the pH of 0.01 normality hydrochloric acid solution and obtain a value 2 according to the universal litmus indicator. According to the precise litmus indicator, I obtain 1.8 as a result. See the difference between the universal and the precise indicator. Let's continue with the next solution, which is 0.001 normality hydrochloric acid, in which we must obtain pH 3. Here, for this solution, I obtain with the universal indicator, I obtain it looks like more as pH 5 than pH 3, the result. Now let's see if there is a mistake with the solution or with the indicator when I use the precise indicator. The precise indicator presents pH 1.8. I check it again to check is there a mistake, and again show the same.
Professor, what's the normality for this solution?
0.001.
Okay, thank you.
You're welcome. Now let's continue with the next solution, which is 0.1 normality acetic acid. Let's see. Let's calculate what we must obtain for this solution. Write down, because I cannot write until my camera is turned on. For that reason, write it alone. I will just leave the screen unlocked to can write down the solution. You have 0.1 normality acetic acid. pKa of that acetic acid is 4.75. No, not 0 point. 4.75. Now calculate the pH according these values. Acetic acid is weak acid. For that reason, we will use the formula pH is equal to pKa plus pCa divided by 2. Can I ask, is there someone of you who is already arrived in Bulgaria?
Yeah, I am in Bulgaria.
And why you didn't come into the, why you didn't come in laboratory?
Because the student's office told me to stay online for now until they tell me again.
Oh, okay. I wait you here to come. I thought that you will come here.
No, that's what they said, because we're still not like all in Bulgaria. So once we're all in Bulgaria, then we will have to attend. But for now, I think we'll just stay online.
And what do you obtain
What?
for the, do you calculate the problem?
I am right now.
Okay. I'm waiting. One plus 475 is 5.75 divided by 2 is 2.88. Now let's check, is it true? Do we actually obtain this value? One piece of the universe. So litmus indicator. Checked. Actually, I don't think you can see it very clear, but it looks like pH 6, not as pH 2. I'll check it with the precise indicator. I will measure with the indicator, which is for area from 1.8 until 3.8. If we see the violet color, means something is not. With indicator looks like 2.7. So the mistake this time is into the universal pH indicator. Very huge mistake. Now I will continue with something which will be very interesting for you if you was here. I will measure the pH of gastric juice, of stomach juice. Actually, this is not a real gastric juice, but according to the scientific value that was proved, we prepared the solution with absolutely the same pH, which must be close to 1.5. The color is changed and looks absolutely like pH 1. Now I will prove this with precise litmus indicator. I obtain 1.8 pH.
Which acid is this?
Can you repeat your question?
Was that acetic acid, the 0.1, or
No,
which?
no, this is not acetic acid.
Gastric juice.
Gastric.
Okay, okay. So it's hydrochloric acid, right?
Yeah, absolutely. The next solution, again, biological material, urine. Urine, what must be the pH of the urine? Close to the neutral or slightly acidic. It must be close to 6. Again, this is not a real solution of urine. I measure with precise indicator number 6 and I obtained for it pH 6.4, the second value. Now I will check what will show me the universal litmus indicator. According to the universal litmus indicator, I obtain value for pH equal to 6. Now that was all acidic solution, I will continue with bases. The first base that I will measure is one of the strongest, sodium hydroxide solution with concentration 0.1 normality. When we speak about strong acid and so concentrated strong acid, we obtain very basic pH, very high value of pH. In this case must be 13, the indicator. Absolutely proved pH 13. Now let's see with precise indicator.
Professor, what base are we using right now?
Can you repeat?
What base are we using right now?
Sodium hydroxide.
Okay, thank you.
Sodium hydroxide, and I obtain pH 13. If it's possible to see something, of course. For next classes, I will take a new camera, or I will find a place with better internet connection. Now let's continue with sodium carbonate solution, basic salt, for which we must obtain again basic value for pH. Very dark green, which correspond to pH 12. Write down for disodium carbonate, pH 12 according to the universal litmus indicator. According to the precise litmus indicator,
It's 0.1 normality.
one normality.
1, okay.
Yeah. According to the precise litmus indicator, we obtain 11. See, same like the first one. And the last solution, which I will measure today, is ammonium solution. With universal indicator, it becomes green, and I obtain value 12. For the 0.1 normality ammonium solution, I obtain pH 12 with the universal litmus indicator. With the precise one, let's see. With the precise one, I obtain pH 10.5. So as you can see, the precise one show the real value of pH. Because let's calculate 0.1 normality to check which indicator show the correct value. You have 0.1 normality ammonium solution. pKb is 4.76. Calculate the pH. Are you ready? Are you ready? Can you hear me?
Yes, I can hear you.
Okay, please write down the solution on the board because when I turn on camera, I cannot write. We have 0.1 normality ammonium solution with pKb value 4.76. What will be the pH that we accept?
We can't write.
Now?
Yeah.
What was PKB again?
4.76. This is the logarithmic value. I obtain 10.62. Oh, I'm sorry, 11. 11. Absolutely correct. So as you can see, the result that we obtained with the precise indicator is the correct one, because with the universal indicator we obtained, what was the result? 13 or 12? Very far from the real result. So that was everything for today. Don't forget to prepare for the test next week.
Which day is it? During practical?
During the practical class, Thursday, 8 o'clock.
Oh, Thursday. Okay.
Okay.
pH and buffer solution.
Okay.
Okay.
Goodbye, have a nice day.
Bye-bye.
Wait, Professor.
Yeah?
I wasn't able to come in the third